Hello, everyone, and welcome to ARG Movement Podcast. My name is Elvira, and today I'm really happy to have Pascal Van Putten here. And hi, Pascal, how are you?
Good. How are you, Elvira?
Yes, I'm also good. So today is actually a very exciting topic because Pascal is the CEO of VPI Instruments. Everyone, I think, knows your company. But I think not everyone knows what you exactly do because so many people buy flow meters, but sometimes they don't integrate the full holistic approach of the system monitoring. So today I want to talk with you about this. But before we start, I wanted to ask you, how did you end up in compressed air and in the flow metering?
Okay, I will tell you the short version today.
Okay.
I started the company about 25 years ago with an invention of my father and my brothers. At the time, it was a flow sensor that could basically measure anything from air conditioning flow to breathing flow or whatnot. We started the company at the time with a prototype of this flow meter, and after typically what goes with a startup is that you have some pivot moments that you have to change your plans a bit. And at some moment, we got into contact with people from the pneumatics, so from machine builders, and people from the compressed air industry, so from the compressor manufacturing
Mhm.
side. And then we got this really interesting inquiry to make an audit tool for one of the major OEMs to basically back up their audit program globally. And that's where it really started off that we also decided to focus entirely on compressed air. And yeah, that's basically what we did and how the company specialized really in this field.
I really love the stories of the family companies, because people really are dedicated to that and really love the subject. But my question is 25 years you started it. What had changed in the industry, in
Oh,
your
there's
opinion?
there's a lot of changes. When we pioneered this, and we were not the first to pioneer this, by the way. There were some people in Germany already doing this from, I think, from Fraunhofer Institute, either maybe even a decade before that we started. But at the time, that I mean, compressed air was not really regarded yet as a very expensive utility. I mean, the energy prices were also different. Um, I think mainly the audits were done and maybe as a way of also selling compressors and selling compressor control systems to optimize the system.
Mhm.
Now, what I've seen now is, I mean, of course, we started with one or two flow meters. That's also a thing. So we started with maybe with selling one or two to a small plant or to an auditor. But gradually, people started to see the benefit of measuring flow, and then they had maybe four or six flow meters.
Mhm.
And then they asked us also, like, okay, could you maybe add other things in this in the flow meter? So there's the trend started also to integrate multiple sensors in one device, which we did back in 2007, if I recall correctly. We integrated the pressure sensor in the flow meter, which is now standard in our flow meter. It's always 3-in-1. But with all that data, there came also the need to basically monitor it and to store it not in an Excel sheet or on a piece of paper, but to store it really in a real-time monitoring solution. So that's when we also started with doing this monitoring. That was already maybe 12 years ago. And yeah, what you see now is, of course, that there is a lot of online IoT-based monitoring going on. Something which then started maybe, if I look back, more than 10 years ago, it's now becoming really the global trend that everybody wants to gather data from machines and try to figure out how to make sense of that data by automatic analytics or by even using deep learning or AI to sort of yeah, get automatic insight in what's going on with the health of a machine.
Mhm.
Yeah.
Yeah, I think it's a trend of the AI machine learning. It's such a huge trend right now. But I'm not skeptical about it at all because I use it is for my research projects. But when I see the difference between it's such a gap, between the research and the real development. When you go to the factory, some factories actually don't have flow sensors at all. So you feel
Yeah.
like, okay, artificial intelligence is amazing, but sometimes just an intelligence would be really nice here to integrate.
Yeah.
Um, just a very like dumb question. Why actually we need the flow sensors, for our listeners? Because there are systems that can calculate if I want to have the flow sensors, for example, for the full system, and I want to understand the full performance of the system, I just can calculate the kilowatt hours of the compressor, check the number, what is the efficiency of the compressor, and recalculate it. So there are many systems on the market, and I saw it myself many times. So what is the uh, actual need of a flow sensor in this cases for the industry?
Yeah, so it's interesting. Some people even see that, or they regard a compressor as a sort of source of truth, right? So they think it's a flow meter, but actually it's not. And one of the problems is that, for example, compressors can change over time, depending on the technology. That can go rapidly or it can go a little bit slower, but in the end, they will degrade over time. And that could result, for example, internally in a leaking drain that you can maybe easily fix. But it could also be that the air end is giving less air out. And if you look at, for example, centrifugal machines, there's a lot of influences also on the inlet pressure, inlet temperature, interstage cooling, etc. So you cannot always rely on what goes in comes out. And I have seen examples also in the field that there can be really a dramatic difference between those two. And the other reason is in the old days, people used power and so power consumption, that is, and pressure as the only signals to do an audit. But if you would try to derive flow from pressure, which is possible, if the pressure goes down, you can do the ideal gas law calculation and get some estimate on flow. But it's a little bit slower, and it's also sometimes depending on the volume of the system, how long it takes, right, before the pressure goes down. So the flow meter is right. It's really the primary straightaway signal that you get from the velocity of the air. It's always faster and more direct than using an indirect method. But I'm not against it. I mean, if you're, for example, you are not able to install a flow sensor in the beginning, or you have limited budget, or you have another reason, you can always start with just measuring and then at least get an insight in, when does the compressor goes on and off? Is it running idle? Or so there is already a lot of things you could also derive from just looking at power.
Yes, so this is basically mostly on the compressor side. I get it. The thing that we also see very often on the side of the machine. So some very often like machine builders, they don't integrate the flow sensor in their
Yeah.
machine because it's expensive, and we will talk about the pricing aspect also later on.
Mhm.
Do you have many cases where you integrate the flow sensors, or what is your opinion? What is the problem of machine builders that they don't do this? Is it
Yeah,
only the
it's
price, or it's in the culture? What is this?
I don't know. I mean, I remember we did once an audit very long time ago for a company that made consumer products, and they had pretty good practice because they always did a benchmark on new machines. So they asked
Mm.
us, could you do vacuum flow, compressed air flow,
Mhm.
power consumption, and they had some other things to measure the glue and or whatever that could get into the machine to produce those products, right? And what we found out is that indeed, if you look at the spec sheet of a machine, it often is based on the cylinder size, the cycle time, and maybe some other things they kind of estimate from the parts they put into the machine. But if the machine starts running, the cycle time could change, or the duty cycle of certain sub-processes can change. They forget that there could be maybe a receiver tank in the machine or not in the machine. So there's a lot of things that affect the actual consumption that you see at the input or at the multiple inputs. And you can also sometimes have that one machine is basically affecting the other one next door or next to the other one because it's consuming so much of air at one point that it basically it drops the pressure basically of the pipe in near the machine. So
Mhm.
uh, so that's one reason. So people use these rules of thumb.
Uh,
And what I also have seen that brand new machines, when they were commissioned or they were made ready for basically the inspection, that there was internal leakage in the machine. It was brand new,
mm.
but there was maybe some contractor did not, tighten the bolts, or forgot to put some sealant in a threaded end or something like that. So then also flow measurement is really useful to see those leakages for brand new machines, and then to fix them, of course, before you start using them.
Don't you think that that is then the risk for the machine builder, that it will actually prove that there is a
Yeah,
problem with his machine?
it can
Or
be stressful because I've seen very complex machines running on air with a lot of bells and whistles on it, and yeah, then you have to ship it next day, and then you discover this leak. What to do, right? Normally people
exactly,
would do like this and probably ship it.
exactly.
Now they see all these things, so I mean that's a good point. You have to be a little bit maybe also. You have to set, of course, the acceptance boundaries right, because maybe it can never be completely leak tight for some reason. So
Yeah.
uh,
Yes, of course. There are, I've seen many applications in food and beverage where they actually have to have leaks because it cleans some parts of the components. So you need to have the valves were not sealed 100%. So you have a leak so it doesn't go inside the contaminants. And I think maybe for the machine builders, it's a bit like harder to get in these boundaries, because another thing you said about the baseline of the machine that is based on the cycles and the cylinders, diameters, and so on. Like if you go even step behind, then you cannot also question the cylinder diameters. Like, are they right? Are they not oversized? Like, is it
yeah,
the baseline is really the optimal energetically? And I think that for machine builders, it will be more interesting to work in the collaboration, like with you, like to have
yeah,
not with you, but in general, like to have actually this full data rather than just hoping that the end user like will not think about this part.
yeah.
So you mentioned you do audits. So it means that you not only produce flow sensors, but you also do audits. Can you tell more about this experience?
We do some we in some countries, and also next door here in the Netherlands, we occasionally do audits, and that could be on at a machine builder or at an end user, or in partnership with a OEM at an end user. And in that case, it's also for us, it's sometimes a learning to see how our products behave in the field, and if it is also good to get insight into any things that we could improve in the future. Really first-hand experience, and sometimes it's really complex. So we are doing right now an audit with about is it like 100 parameters at the same time, so per second. Uh, so very complex. It's really beyond what you normally would do in the world of compressed air. But it's better to get insight really in very tiny details of this specific process.
Okay, so you mean
Uh,
100 parameters not only on the flow in the different points, or there are also other parameters of the
yeah,
machine
flow.
performance?
Yes,
Flow.
flow, pressure, machine cycle frequency, that kind of things. Yeah.
Okay, amazing. So it means that you collect actually a lot of data also to train your system and to analyze better in the future.
Yeah.
Let's talk about the monitoring part.
Mhm.
I see a lot of systems, and sometimes clients like say, yeah, we don't need another monitoring. We have our basic monitoring for the
Yeah.
for our plant. It has a nice colorful dashboards. Here it shows like kilowatt of the compressor. They have like a difficulty. I think it's more like the experience maybe, and just like not very open to
Mhm.
implement it, because it's just like lack of personnel who is
Yeah.
responsible only for this utility, such a compressed air. So what is your experience with the monitoring like software and the integration for
Mm.
customers?
Yeah, there are different reasons sometimes to choose for certain solutions. So there's not really like a one size fits all answer to do this. So sometimes you have a big corporate which has a nice BI system with fancy dashboards, and they can do anything with it. And if the people are well trained on that, there are cases where you just supply the sensors and they integrate it and it works fine. You also have, of course, companies that don't have much centralized data acquisition, because they might have some production machines, and they might be connected to their CRM or to their ERP system, but that's it, right? So in that case, it can make sense to have a separate system to monitor the data, also because of redundancy, because of safety, that you don't have to mingle with an existing system straight away. and implementation time can be much faster also. So in that case, we do, for example, we install our product, or sometimes we have distributors that have their own platform, and they can install it in a matter of days and have a live dashboard. And yeah, basically have a system dedicated for the compressed air from the supply to the demand side. The other thing is, if I take our own VP Vision as an example, it's real-time once per second logging. And a lot of energy management software platforms, they take maybe 5 or 15 minutes as an
Okay.
average. And then you miss those events, like if there is a pressure drop or a peak in the flow, you will miss it. So there can be also a very good reason to have this once per second logging, and then maybe use the average numbers for your, let's say, your energy billing or your cost allocation. But you want to have that other data to optimize your control system, or to find issues with lack of receiving, lack of storage tanks, for example, in your network, and so on.
Yeah. Okay.
Yeah.
Okay. So basically, you also can integrate it in their systems that they already have, but you also can use it. You can provide your system if they want to have more
Yeah.
precise monitoring.
Yeah, and the
Um,
most, let's say the most simple way is, of course, you take a flow meter, like I have it here. It's a little bit
yeah, I
blurred,
see it.
like
Yes.
the flow
Uh-huh.
meter, and or you take something else with a. This one has a built-in data logger,
Mm-hmm.
and then that's a sort of data acquisition system on its own. So that's really the most simple way you can start with a data logger and a sensor, and then just get the data out of there.
Okay.
Yeah.
Okay. Let's talk about other more aspects, more like business aspects and integration of the systems. I mean, how difficult it is to implement, because you always like hear this yes resistance a little bit from energy managers. To implement the flow sensors, we need to completely stop our production.
Okay. Yeah. So.
What is the time? What is the difficulty? What kind of the people you need to have to install everything? Do you actually need to stop machines for that?
You don't have to stop machines all the time. It also depends a little bit on the type of flow meter you install. If you take, for example, an insertion probe, which is basically a small stick like I just showed here on the screen, right?
Mm-hmm.
Basically, need to drill a hole in the pipe with the size of this probe. And
Okay.
there are companies that can do that for a fixed price per installation point.
Mm-hmm.
So you can easily prepare your installation with those points. Yeah, that's not a big problem to prepare it, and then you can later decide to put a flow meter in, or maybe put multiple flow meters in, and even move them around in the factory if you like. Now, if you have an inline meter, it might need that you have to shut down the machine. So you have to do it maybe at Friday afternoon or during lunch break or whatever.
Mm-hmm.
Most machines will have a shut-off valve anyway from the central network. So you close the valve, put in the flow meter, and then there you go.
Mm-hmm.
Also
And it's
technologies,
yes,
yeah,
go ahead. Mm-hmm.
yeah. There are also flow meters like clamp-on ultrasound. We don't produce those, but
Mm-hmm.
in some cases where there is really a lot of risk, like there's contamination risk or there is certification issues, that is
Mm-hmm.
all certified welding, for example, then you could consider to use basically an ultrasound clamp-on meter, but it comes with a price. So the price is tenfold at least of a simple thermal mass flow meter. Plus, it comes with technical, and we have a presentation on that. But there's also limits on clamp on ultrasound meters in terms of
Okay.
their signal to noise ratio, etc. So
What
it's
is the difference from these measures? I mean, like the 10 times price, it's you always have in your head, okay, it's 10 times more expensive, it's 10 times better. So what is how the customer can actually decide
Well,
which
it's
one to
really,
choose?
really expensive, of course, if you have to recertify your pipe work,
Mm-hmm.
or if it's like food grade, or if it's whatever special high pressure pipe work, and in that case, you probably can do the math yourself as an end user that it's maybe wise to use such technology. But if you want to have like I don't know 50 measurement points in your plant, then to use thermal mass flow meters is really the most cost effective way as of today.
Mm-hmm. About the cost-effective way, even if it's cheaper than the ultrasound, I often hear from some people that flow meter is very expensive, you know. But then
Yeah.
if you think about energy audits and how much money you can save actually by knowing the data, it feels like that it makes sense.
Yeah.
So it worth it. So what is your experience with the customers? You know, like
It depends a bit on the country, but I mean, I always compare it to what's flowing through the pipe. Like a 2-inch pipe can be 100,000 euros a year worth of
uh-huh.
air flowing through there. So why not put a few percent of that money into decent sensing of what's going on? So, but yes, we get the argument. What we always do is we calculate back from total energy costs. So
Mm-hmm.
we get total energy costs associated with the utility, and then we say, let's make a reasonable initial investment based on your expected return on that investment. So if you spend 100,000 on compressed air, you can take 10,000 as your initial investment for the total monitoring solution, for example, to start. That's very safe, right?
How many sensors? How many sensing points would be for
I
10,000?
think you would talk then about, for example, four compressors that being measured with power, dew point sensor, and for example, one main flow meter, something like that,
Mm-hmm.
start point with monitoring software. Just as an example, don't I mean the numbers are just now estimated, but it's more the line of thought. You should always
Yeah,
rely
of course, yes,
your investment on the return on your investment, and don't overinvest on sensors, because then you might discover that you are measuring in a dead end where there's no flow at all, or you might measure a machine which is really small. So
exactly. You just need first to have an idea also before what are the possible energy savings, like
yeah,
at machine, at the line where you have problems or critical points, and then you can already put the sensors. So your system is more sustainable. So it gives you then the data, you have an
yeah,
action plan, and it pays back rather than you invest 50 sensors and
exactly.
then you blame Pascal that you sold like 50 sensors and you measured
Yeah,
the dead
I
end.
mean, correct. And you will see that. I mean, we have customers that start with this on one of their plants, and then they do another one, and you learn
Mm-hmm.
the way that, okay, we have done this. Let's say we have a best in class example, and what we
Mm-hmm.
do, you review it, and then you say, okay, let's copy paste that method to other plants, and then systematically basically work your way through it.
Yeah.
It's more like an agile approach in that sense.
Yes. So, Pascal, one of the first on the market for the flow sensing, 25 years in the industry. What are you working now? Like, did you already solve all the problems of the flow metering in compressed air?
Oh,
What is going on there right now?
we have some new developments. We showed last year also in Hanover. We are working on a new inline model for basically that fits in the Flowscope M product line. Means that it's IoT ready. It has an option for Ethernet output. And most importantly, it's very easy to install and very easy to service. We also continuously working on new software iterations in our monitoring platform, as well as the configuration software that we have for our products. Yeah, and there's some more things coming out, but I cannot tell everything right now. But yeah, basically check us out on the website. And if you're interested in evaluating one of our newer products, you're always welcome to contact us and talk about it. Yeah.
That's great. And one last question, like on the personal side, like how do you what is your motivation mostly? Is it like some scientific interest to improve it? Is it to reduce the energy consumption of the factories, like to make the world more sustainable? So what actually drives you for so many years, like keep
Mhm.
going and still like developing new and new things and not
Yeah.
just like selling the products that have been developed 20 years ago? What is your
Yeah,
drive?
I like things to be to make complex things easy and accessible for a lot of people. So indeed, a lot of companies worldwide can save that energy, because I think it's the greener planet really starts with energy savings, and then in combination with also alternative energy sources. But energy saving is really such an easy way to already lower our complete carbon footprint. And also, if you look now in the Netherlands to, for example, to free up capacity in the national grid, which is kind of,
Exactly, yes.
uh, and that's my personal motivation is indeed to make the planet a bit greener. and then using my expertise, which is sensors, easy to use products, and easy to use software, and then do that here together with a lot of people in the company that are also passionate about that. Yeah.
Yes. Well, Pascal, I wish you a lot of another 25 years of successful experience and new products. So we're really waiting for that on the market. So we'll keep a track also on that.
Yeah. Thank you.
Thank you so much. And thanks to our listeners to join in our interview today.
You're welcome. Thank you. Have a nice day.
Thank you.